Well, to describe the properties of this graph, we're going to be using the graphing calculator. Later in the semester, we'll be able to do this without a graphing calculator. So y equals x minus 5 and then square root x minus 1, and then zoom standard and take a look at the graph. Well, one thing to notice is that the function begins at x equals 1. For anything less than 1, the function doesn't even exist. And that's due to this. We're not going to be graphing any complex numbers, so what's inside of the radical needs to be positive. So x needs to be a number bigger than 1. And actually, we should try and see, what about exactly at 1? Yes, that would work. So it begins actually at 1, comma 1. So first of all, sketch a graph of it. So it starts at 1, comma 1. It swoops down. And then I need to see what happens over here, if it flattens out or if it goes back up. It starts just right there, looks like it's going back up. So change the window and have the x values go out farther than just 10. Let's say 20. And then go back to the graph. And sure enough, it does go back up. Now I'm curious to see, does it go past the x-axis? Does it keep going up forever? So I need to change the window again and have x go out to maybe 50. Oh, sure enough, it does go up forever. So it swoops down, but then goes up forever. So it looks like it's got a minimum value down here. We can use the calculator to find that. If you go to second, calculate, find the minimum. What the calculator wants now is pick a number on the left where you think the minimum is. So I would say x equals 2. Okay, yep, that's on the left of it. You can then type in another number such as 12 or something like that that looks to be on the right of it. Or you can just move the cursor to be somewhere to the right of where the minimum is. And then your guess as to where the minimum is can be approximate, such as this. Hit enter, and it will find the minimum value. So it's got a minimum at 7.25, comma negative 5.25. It begins at 1, comma 1. So it's decreasing in this area. So decreasing. And when we give the interval for where functions are increasing or decreasing, we talk about the x values. So that would be from x equals 1 to x equals the 7.25. So from x equals 1 to 7.25. And then exactly at 1, we can include that point, as we saw when we substituted in a 1 earlier. But at this point, when it gets to the bottom, it's not actually decreasing anymore. It's gone down, reached the bottom, and then it's going to be going back up. So at 7.25, we don't say that it's decreasing. So put a round parenthesis on that one to say it gets as close as you want to 7.25 while still decreasing, but not exactly at 7.25. And then, where is it increasing? Well, that's this right-hand side. So from 7.25, and again, not exactly equal to it, but as close as you want, so use a round parenthesis, and then forever, to infinity. And there's a description of the graph.